Today we're going to look at problem number 2 in Michael Spivak's calculus. And this is a very famous problem because essentially it's an evaluation of a proof. And the proof is 2 is equal to 1. Now, in order to evaluate this proof, we need to take this argument line by line. And so then the first argument they have is they're going to let x equal y. Okay, so if x is equal to y, what we do next is we multiply both sides by x. And now if you have x times x, we can say that this is equal to x squared, and the other side is xy. Now this is a very fine equation right here. This is not an issue. Now we look at the next line of the equation. X squared minus y squared. Now, this is a fine part of the equation too, because every real number has an additive inverse. And so what they're doing is they're subtracting by the additive inverse of y squared. So this is another correct statement. And now we see the next statement. This one right here. Now, if you've seen the previous videos, you know that this is a property we've covered. X squared minus y squared is equal to x plus y times x minus y. This is essentially factoring or reverse distribution, which is another perfectly fine argument to make. So right here we have x squared minus y squared is equal to x plus y times x minus y. And this is equal to y times x minus y. Now we look at the next part of the equation. Right here, x plus y is equal to y. Now here's where we get into the issue. What they've essentially done is they multiplied by the multiplicative inverse of x minus y. And this is where we get into the problem of the proof. So the reason why this is not possible is that even though every number has a multiplicative inverse, so all real numbers have a multiplicative inverse, meaning a times a to the negative 1 is equal to 1, except for the particular number a equals 0. Now, the thing with x minus y, this right here, is equal to 0. Why? Because of our initial assumption. Our initial assumption was x is equal to y. So doing this step right here, multiplying both sides by the multiplicative inverse of x minus y, is impossible. And that's why this proof is incorrect. Because of this step right here. This is not possible. And that is what is wrong with this proof.